Let's begin our new unit in our journals today. Please go to your table of contents and write the atmosphere, then go to the appropriate page in your journal and begin your notes on Chapter 6, the atmosphere. If you were lost in the desert, you could survive for a few days without food and water, but you wouldn't last more than 5 minutes without the atmosphere. So the atmosphere is such an important part of our lives. Let's begin our discussion. Our atmosphere is a mixture of gases that surround the earth. It contains nitrogen, oxygen, and a variety of other gases. Our atmosphere is made up mostly of nitrogen, 78% of it actually, and that is formed by decaying plants and animals and volcano eruptions. 21% of our atmosphere is made up of oxygen. Oxygen in our atmosphere is formed by plants and phytoplankton. The other 1% of our atmosphere gases is made up of argon, carbon dioxide, water vapor, and other gases. This holds our atmosphere to the earth, and it causes air pressure to occur. Let's think for a moment and see if you can determine what's going to go in the blank. What is it that holds the atmosphere to the earth and causes air pressure? If you thought it was gravity, you were correct. Gravity is what holds our atmosphere to the earth and causes air pressure. So what is air pressure? Air pressure is the measure of the force with which air molecules push on a surface. Air pressure at the surface of the earth at sea level is 14.7 pounds per every square inch. We typically will round that to 15 pounds per square inch at sea level. So let's think about what that means. Per square inch is, if you think of a postage stamp on your body, and then you have postage stamps completely all over your body, that's 15 pounds of pressure on each postage stamp size of your body. Wow, that atmosphere that's piled up on that one little inch on your body is 435 miles of air that is piled on each of us at all directions on our bodies. Now, there's some concepts that I'd like you to understand. So look at the pictures that you see there below. There's a picture of a really high mountain, and there's a picture of people who are hiking on the mountain. So let's talk about those. As you go up higher on a mountain, something occurs to the air pressure. So as you're hiking up a mountain, think to yourself, what happens to the column of air as you go up higher? Does it get less? Does it get more? So pause and think about that for a moment. So if you thought as you go up higher that there is less air pressure, you were right. That's true. The column of air gets smaller the higher you go up, because the atmosphere, your height in the atmosphere is getting higher. The next bullet point says the higher up you go, this happens to the temperature. So think from your past experiences when you've gone on field trips to Bays Mountain, and you think about the temperature here in Kingsport compared to the temperature at Bays Mountain. The higher you go up a mountain, there's less air pressure, there's less atmosphere. So the temperature does what? Pause and think for a moment. So the higher you go up, if you thought the temperature gets cooler, you were correct. The higher up you go in our atmosphere, the colder the temperature becomes. If you've ever flown on an airplane before, you would notice that you see condensation on the outside of the windows of the airplane. Sometimes you might see little crystals of ice also. That's because it's really cold the higher you go up in the atmosphere. There are not as many gases in the higher parts of the atmosphere that can absorb radiation from the sun. Therefore, the temperature is colder. Let's look at the last bullet point on this page. So if you were wondering, what is the elevation of Kingsport? Sea level is considered 0. So guys, that is the point where the sea meets the land. That is 0 feet. Kingsport, as you leave the ocean, is 1,208 feet above sea level. Let's look at this diagram of the atmosphere. So the layers of the atmosphere are defined by changes in temperature. So here at the top, let's look at the layers of the atmosphere here. So the lower pressure is on this end. The higher pressure is on this end of the picture. The lower temperature is, let me move my cursor here, is on at the bottom is when it's a lower amount of pressure. The higher you go up, the temperature is colder and it has less pressure. As you look at the diagram down here below, the higher the temperature is when it's warmer down here. You have a higher pillar or column of atmosphere pushing on you. As it is a high pressure, notice as the pressure becomes less, you go higher up in the atmosphere. The temperature also is less. Let's look at the layers of the atmosphere. Starting closest to the earth is the troposphere. As you go up, there is the next layer, the stratosphere. Then higher in the atmosphere yet is the mesosphere, and then the thermosphere. Friends, thank you for listening today and writing those notes in your journal. Make it a great day. The choice is yours.